Good morning, everyone. As we have already discussed, we are going to discuss today the condensation reactions in carbonyl compounds. So first of all, we need to understand what do we mean by condensation reactions. Condensation means the addition reaction followed by elimination of some small molecule. So, if we are asked what is a condensation reaction, we say a chemical reaction which includes addition or combination. Of course, both are the both have the same meaning, which includes addition of two molecules, reagents, whatever we say, followed by elimination of small molecule like ammonia, NH3, water, H2O, etc. are known as condensation reaction. So basically, we mean addition followed by some elimination is known as condensation. Here, when we are discussing the carbonyl compounds, we have aldol condensation to begin with. Aldol condensation, this reaction is named aldol because the product after the first step includes a molecule which has aldehyde as well as alcohol. So the word aldol is derived from two functional groups, one aldehyde and the second alcohol. Here, any carbonyl group, that is aldehyde or a ketone, having alpha hydrogen. What is alpha hydrogen? Here, this carbonyl carbon is bonded to some sp3 hybrid carbon directly. Then the hydrogens of this carbon are known as alpha hydrogen, and this carbon is known as alpha carbon. We may have carbon atoms bonded to this carbonyl carbon on either side, so we may have different number of alpha hydrogens, but the presence of alpha hydrogen is must. For example, here I have taken a molecule CH3, CO, CH2, CH3. Here, this carbon and these two carbons are directly bonded to the carbonyl carbon. So the hydrogens of these carbons are known as alpha hydrogen. This molecule has 5 alpha hydrogens, 3 bonded to this carbon and 2 to this. We must make one thing very clear, that the carbonyl carbon must be bonded to the sp3 hybrid carbon. The sp2 or sp hybrid carbons bonded to this this carbonyl carbon, even if they possess some hydrogen, we do not consider them alpha hydrogen, and these molecules do not participate in aldol condensation reactions. So I'm writing a few aldehydes and ketones, and you need to tell if the number of alpha hydrogens in those given compounds. For example, the compounds are named here, and you need to tell me the number of alpha hydrogens. First of all, HCHO, then CH3CHO, CH3CO, CH2 double bond CH, COCH3, CH2 double bond CHO, and benzaldehyde. So going to find the number of alpha hydrogens bonded to these carbonyl carbons. This is the only carbon that is the carbonyl carbon. So there are no alpha carbons. So no point of finding any alpha hydrogen. So number of alpha hydrogens 0 here. This carbonyl carbon is bonded to one sp3 hybrid carbon, and this carbon contains 3 hydrogens. So there are 3 alpha hydrogens in this compound named as acetone propanone. This carbonyl carbon is bonded to two sp3 hybrid carbons on either sides, and both these carbons contain 3 hydrogens each. So number of alpha hydrogens in this compound is 6. This compound is bonded to an sp2 carbon on one side. sp2 carbons, even if they have hydrogen, these hydrogens are now not counted as alpha hydrogens because these are not going to release this hydrogen, and these carbons are actually involved in resonance here. But this carbon, this one is sp3 hybrid, and the hydrogens of this carbon are considered as alpha hydrogens. So we have 3 alpha hydrogens here. In this case, the carbonyl carbon is bonded to a carbon that is sp2 hybrid, so no alpha hydrogens this time. And here this benzaldehyde, this carbonyl carbon is bonded to sp2 hybrid carbon again, so no alpha hydrogens. So if we are asked which of these following compounds, these given compounds, are going to give us aldol condensation, then the compounds having alpha hydrogen can undergo aldol condensation. That is acetaldehyde, acetone, and this molecule. What do we call it? 1, 2, 3, and 4. We number this carbon chain from the side where the functional group is closest, that is the right hand side. So this is but 3-ene-2-one. So these 3 compounds will undergo aldol condensation. Next, we see what is aldol condensation, what occurs there. I am taking general aldehyde molecule RCH2CHO, and it undergoes condensation in the presence of dilute NaOH with some heat provided to it. I have taken 2 moles of this molecule. Then in this reaction, what do we find as a product? As a product, we find RCH2CH double bond C R CHO. This carbonyl carbon is directly bonded to this carbon, so this carbon will be considered as alpha, and this one the beta. So as a product we have alpha beta unsaturated aldehyde. This molecule has undergone aldol condensation in the presence of a weak base, that is dilute NaOH, and a little of heat provided to it. Undergoes aldol condensation to form alpha beta unsaturated aldehyde. The mechanism of this reaction we are discussing the next, how this reaction proceeded to give us this product. In the first step, we have this aldehyde molecule and we have treated it with base NaOH. So OH minus is present in the solution. Since carbonyl group C double bond O is a strong electron withdrawing group, so it withdraws electron and hence this carbon directly bonded to the carbonyl carbon becomes electronegative, and hence it withdraws electron from this carbon, and this carbon can be easily extracted. We have taken a base, and what is a base? Base is something that can accept H plus. So OH minus attacks on the acidic hydrogen, that is the alpha hydrogen. This electron is moved towards the alpha carbon of the carbonyl compound, resulting in the formation of an anion. Now this anion attacks as an attacking reagent to the other molecule, that is the same aldehyde molecule. This negative charge attacks on the carbonyl carbon, as we have already studied that this anion acts as a nucleophile, and these aldehydes and ketones undergo nucleophilic addition. So this negative charge, that is this nucleophile, this anion attacks on the aldehyde molecule. This is the rate determining step. So by the attack of it, what do we have? RCH2. This oxygen, carbon oxygen double bond, the pi bond is broken and the electron has moved towards the oxygen. So oxygen has gained a negative charge, and this carbon is bonded to the nucleophilic carbon. This species is formed. Now this anion gains H plus from water, and we have RCH2, CH, OH, CH, CHO, and here the carbon chain. This molecule, as we see, has an aldehyde as well as an alcohol. So this product is named as aldol. If we stop this reaction here, we do not heat. If heat is not supplied in the reaction stops at this very moment, and the final product is aldol. But condensation occurs after the formation of aldol if heat is provided. We still have the base in it, and the CHO group keeps on withdrawing the electron, making this carbon, that is its vicinal carbon, electronegative. So the hydrogen of this carbon can be easily taken out by the base, forming another carbanion. So now we have this carbanion. Because of the formation of this carbanion, the OH leaves out, and we have our final product RCH2, CH double bond C, CHO bonded to R. This is our final alpha beta unsaturated aldehyde as a product of this aldol condensation reaction. This elimination part, after the formation of aldol till the alpha beta unsaturated aldehyde, this reaction is even CB, that is elimination unimolecular by the formation of conjugate base. Since H plus is released, there is a negative charge, and this molecule is known as conjugate base. So this mechanism of elimination is even CB.